So let's try to explore hydropower. And in order to do that, because we are talking about hydro, which is water, we need to understand the water cycle. The main reason that hydropower is considered renewable energy is because of it is based on the natural water cycle process. So here, as we see in this water cycle, the heat of the sun, which is solar energy, is actually driving the water coming from the sea to evaporate. So the evaporation of this water goes towards the cloud to form into a clouds, and then the clouds also precipitate into rain or snow, and so it goes back to the ground again. Since this whole cycle of a continuous cycle is basically maintaining the total amount of water in the air, so it's basically sustaining. So it's renewing itself. So in the same way, when we use water in this way, we say it is renewable because it's self-sustaining. And so if we try to see the history of hydropower, in fact, people have utilized the power of moving water in the ancient world, or even for more than about 2,000 years ago. So they are basically used for irrigation, even for mining. And one of the first uses is the water wheel, this part here. So this water wheel is basically placed along rivers and flowing streams. So even at ancient times, people have recognized that we can actually use the force coming from the flowing water. So due to the flowing water from the river, the wheel is turned. Okay, so coming from the river, for example, here, the wheel is turned, and then this shaft here is connected to millstones, for example, that eventually grind some grains. All right. So some of the early designs for this part is the undershot design. So if you can see, there's two kinds of designs here. The undershot is where the water is flowing from the bottom of the wheel. So it's turning the wheel from the bottom here. But because of these designs, you can see this is quite inefficient design. So it's not actually powering the wheel as much as it can. And so an improved design is what we call as an overshot water wheel. So water is coming from the upper side, and because of this, it has also tried to improve the design of the blade, as you can see, compared to this part here. So the blades can capture more of the water or the flowing water. So now it has increased its efficiency up to even 66 or more than 66% efficient. So it can convert mechanical energy or the kinetic energy from the water into work, into mechanical energy, for example. And this is just a simple example of how flowing water is actually used to turn the wheel. And so this could be a form of overshot design, but not exactly like this, but this is a modern, a simple water wheel that is used for some kind of putting some work. And so all of these into the basis of using the energy from water to generate electricity. So this because of this history, these experiences, it has now come to the point where water is stored into high ground like dams, and even for the high force of the flowing river can be used to generate electricity. So before it was more of mechanical, from kinetic energy to mechanical energy, but now it's more of transforming the kinetic energy from water or potential energy from water into electrical energy. So now we're going to discuss some of the approaches on how to generate these energy forms of energy. So hydropower in this case is basically using the force or energy of moving water to generate power. In this case, we're generating electricity. So we can see two main kinds of hydropower we are referring to here. The hydropower is actually considered as the most advanced and the most mature and the largest renewable energy technology source. And as of this moment, it accounts for around 70% of the total renewable energy generation around the world, and it can produce up to 450 gigawatts of electricity based on the 2015 figures. Or this translates into about almost 4,000 terawatt hours of energy, or about, as I said, 450 gigawatts of electricity. And it has been used for more than 160 countries around the world, and including Australia as well. We have a number of hydroelectric power stations in Australia. And the biggest one in the world now, in terms of generation, is in China. So we will the Three Gorges Dam in China is the biggest around the world in producing energy. So when we talk about hydropower, there are basically two ways of harnessing the energy by turbines in the hydropower. It is based on potential energy, which is associated with water confined behind a dam, or what we say as the elevation. All right. Okay. So we're using the height of water to have that energy source. And the other one is kinetic energy, which is associated with flowing water. And normally, this is done in river flows. And if we have a strong flow of the river, we can utilize that to generate electricity. So the first one that we have is a potential energy. And this potential energy is based on the dam systems. All right, so we need to confine, we have to build a very large dam. So that behind this, so this is the dam here, and behind this is a really large body of water, and it has a height. So there must be a different in elevation from here and to this part. So you can see there's different parts of the dam system. And normally when you talk about potential energy, the use of potential energy, which is associated with the use of dams, this is used for what we call as high head hydroelectric facilities, high head. So it means that's a very high elevation. So there's an intake part here, there's the dam level here, there's an intake part where the penstock or a pipeline that goes down towards the turbine. So the turbine is here. All right, so there's a turbine that is connected to the generator. So once the water is flowing, as you can see, it turns the turbine around, and the turbine is connected to the generator, and the generator generates the electricity. And so this electricity now goes to the transformer and now goes towards the utility grid. As you can see from there, there's the transmission lines. And so the water is flowing from top to the bottom here, going towards some pipes lines and goes towards the river systems. All right, so in this kind of configuration, it has very high head, so the capacity is also quite high. It's around greater than 10,000 megawatt of electricity. Okay, so this is a very high power generation. If you compare that one to the use of kinetic energy, so we are talking about what we call as run-of-the-river systems. So it means we can either put directly towards the river flow or make a mini dam in the river. So this is a river, and the main thing about this configuration is you must make sure that the river has forceful enough to generate the electricity. So if you compare the two, the elevation of this is quite lower than compared to this, of course. At the same time, in terms of power generation, the energy that is produced here is also quite low compared to the high head systems or the potential energy. The good thing about this one is it doesn't really restricts the flow of the river, so it's good for the environment. And while in this case, if you look at this one, you need a really large space, and also you need to have a fixed system here that may also affect the environment or surrounding areas. And it has a lot of issues about building dams. So as of this moment, for example, in Australia, we're not building any new dams because of some issues in terms of the long-term effects, and even for the issue of decommissioning. Once the lifetime of this one is finished, how to decommission this project. So we will discuss some of the issues and concerns with regards to hydropower or hydroelectric power stations. But in terms of the capacity to provide electricity, this is a very, very major part of renewable energy technologies because many parts of the world have water, and also we have space, so we can potentially generate enough electricity if properly designed. So normally the plant life is very generous for the dams, and for this system is around over 50 years, and so it really has a very long life. As I mentioned before, there are dams and reservoirs and run-of-the-river system. So these are the two main types of these hydroelectric power stations. The third one here that I mentioned that I put here is actually pump storage. So this is pretty much similar with dams, but this is more of an energy storage technology. So it stores energy rather than um, generating the energy. So we will also discuss this one in the next slide.
Hydropower. Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydroenergy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator which produces electricity when the turbine spins. There are two main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity. Large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. The Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people. Of all renewable energy sources, hydropower holds the largest share of worldwide electricity production. Hydropower has several benefits. It is a cost-competitive form of electricity, even though the initial building cost can be high. It is quite reliable compared to other renewable options and pairs well with other sources as it can be used as baseload power. In some cases, dammed reservoirs can also help with flood control and be a reliable water supply for communities. There are also some concerns with hydropower, especially when it comes to large dams. Damming a river has a major impact on the local environment, changing wildlife habitats, blocking fish passage, and often forcing people in riverside communities to move out of their homes. In addition, dam failures can be catastrophic, claiming the lives of those living downstream. Hydro plants are also not completely free of greenhouse gas emissions. As with most forms of energy, carbon dioxide emissions happen during construction, particularly due to the large quantities of cement used, and plant matter in the flooded areas makes methane, another greenhouse gas, as it decays underwater. That's hydropower.